The laboratory fume hood. Perhaps no other item in the laboratory is so common, yet so misunderstood. It is protective equipment. Its job is to contain, capture, and remove toxic fumes for the protection of the operator and laboratory personnel. Those who would complain about having to use the fume hood need only to consider the alternative.
An effective chemical hygiene plan does not have to be overwhelming. Develop one that makes sense for your particular situation. Then make sure it is documented and followed. This video can help you develop the fume hood part of that chemical hygiene plan. Hi, I'm Vicki Verdery. I'm here to help you better understand your fume hood system, how it works, and the do's and don'ts of fume hood work practices. In the past few years, much has been learned about the proper design, installation, operation, and maintenance of fume hood systems. Now our job is to make sure fume hood users are aware of this new information that helps make their work environment safer and more pleasant. That's why this video was created, to dispel the myths and misconceptions surrounding fume hood systems.
Myth number 1. A new hood is a good hood.
Don't let the age of a fume hood fool you. For any number of reasons, even a newly installed quality fume hood may not perform efficiently and may be out of compliance with regulations. So test and verify that your fume hood is working properly for its intended purposes.
Myth number 2. If your fume hood sounds like it's working properly, then it is working properly.
While a strange sound may indicate that something is wrong with your fume hood, do not assume a good sounding hood assures you of safe operation. If you aren't qualified to test your own hood, then make sure that someone who is trained and experienced does test your fume hood's performance on a regular basis. And record the information. Don't rely totally on a simple visual test. A dancing tissue is hardly scientific. Besides, if you don't pay attention, they may temporarily clog up your system and put you at risk. Which leads us to myth number 3, the granddaddy of them all.
Myth number 3. The faster the face velocity of your fume hood, the better it is.
Faster is not always better. In fact, high face velocity may create unwanted eddies inside the hood. Face velocity? I'm so glad you asked. Airflow is created by an exhaust blower that moves the air from the laboratory into and through the duct and stack for release into the atmosphere. The air moving into the hood creates a face velocity at the hood opening. This face velocity is measured in feet per minute. Know your fume hood's face velocity. It's important. If it measures too high or too low, it could spell trouble for you.
The new common wisdom is that face velocity should be 80 to 120 feet per minute, depending on application and other factors. Face velocities of 120 feet per minute may be advisable under certain unusual conditions. A face velocity less than 60 feet per minute is generally considered by experts to be undesirable. On the high end, a face velocity of more than 150 feet per minute is also generally considered undesirable. High face velocities can create eddies that can cause spillage of fumes outside the hood and into the operator's breathing zone. Likewise, low face velocities may allow fugitive emissions or diffusion out of the hood. Low face velocities may not overcome room air currents and cause spillage.
So know that your face velocity is right for your application, if not for your sake, for your company's sake. To better understand your fume hood and how it can work for you and not against you, let's take a look at what makes up the entire fume hood system.
The fume hood, the duct, the remote blower or built-in integral blower, depending on your hood and possibly an air cleaner or scrubber, and the outside stack work together to contain and exhaust contaminants. There are many types of fume hoods to match your budget and need. The top 4 types are the bypass fume hood, the auxiliary air fume hood, the conventional fume hood, and the increasingly popular variable air volume, or VAV fume hood. Also, there are many specialty hoods. The perchloric acid and radioisotope are special hoods, not to be confused with the airflow design.
The most popular fume hood in use today is the constant volume bypass fume hood. Most have a movable vertical sash and are attached to a remote blower. Lowering and raising the sash compensates and minimizes high velocity airstreams that could create eddies. The top and bottom bypass openings reduce air velocity fluctuations that could otherwise disturb laboratory experiments. The baffles in the back of the fume hood cavity are preset at the factory. However, they should be reset at your location. Contact the hood manufacturer for details. Furthermore, you, the technician, should report any damage or tampering with the baffles. The airfoil, which is right here, baffles and other special designs of fume hoods improve containment. If you reduce air turbulence, you reduce spillage. And if you reduce spillage, you reduce exposure to contaminants. And that's the whole point of engineering controls, such as bypass fume hoods and other types of hoods to keep you, the laboratory technician, below permissible exposure limits of hazardous chemicals. Another type of bypass constant volume hood is the auxiliary air fume hood. You may know it by another name,
such as add air, makeup air, induced air, or balanced air. The auxiliary air fume hood was initially seen as a simple and dramatic way to conserve energy and reduce energy costs.
You know, Mike, another type of fume hood is the conventional with special sashing. This is the least expensive of the fume hoods. It has a movable sash in the front and baffles in the back interior. It generally operates at a constant exhaust volume. All the exhaust air enters the hood through the sash opening. It doesn't have bypass openings at the top and the bottom of the sash as the bypass fume hood has. Therefore, as the sash is closed, the speed of the air increases through the remaining sash opening. Thus, very high face velocities can occur when the sash of a conventional hood is almost completely closed.
And I'll bet that high face velocity can create any number of problems.
That's right, Mike. High face velocity can damage delicate apparatus. It can adversely affect instrumentation, extinguish Bunsen burners, and create eddies inside the hood cavity.
And high face velocities can disperse valuable sample materials and cool distillation columns, too. That's why many labs prefer bypass hoods more than the conventional.
Some industrial hygienists believe the variable air volume fume hood is the wave of the future. Although initially more expensive to purchase and install, variable air volume, or VAV fume hoods, can offer better energy savings than other hoods. This is accomplished by varying the amount of air that gets exhausted. That is, VAV hoods vary the amount of room air exhausted while keeping the face velocity within preset parameters. VAV systems must also vary the room air supply. Variable air volume hoods alter the exhaust volume in different ways. One type uses a damper that opens and closes based on airflow and sash position. Another method utilizes varying blower speed to meet air volume demands. VAVs are considered to be the most sophisticated of fume hoods available today. VAVs can benefit lab technicians, particularly those who perform lengthy and complicated experiments. And VAVs can be equipped with monitors and alarms, which can alert the hood user of unsafe airflow conditions.
Today, there are an estimated 250,000 to 1 million fume hoods of all types in the U.S. alone. They are lined with a variety of different materials, depending on application. Take a look at all of your fume hoods. Know each one's materials of construction and capabilities. Ask your chemical hygiene officer for specifics. It pays to look beyond your fume hood. Know all of its components. The design, layout, installation, operation, and maintenance of the fume hood, the duct, perhaps with an air cleaner, the remote blower, and the stack are crucial to fume hood performance. Your fume hood stack must be high enough to release the fumes up into the atmosphere and not allow them to recirculate back into your building and into the breathing zones of others.
But why should you care?
Because it might increase more than just the life expectancy of your fume hood system.
Do keep your sash as low as possible during operation. Don't quickly raise and lower your sash. Do work 6 inches behind sash opening. Don't have a close call accident without realizing it. Do elevate equipment about 3 inches above hood surface. Don't work while standing inside a walk-in hood. Do select the right hood for your application. Don't overcrowd your work surface. Do follow OSHA regulations. Don't use perchloric acid in a non-perchloric system. Do keep a well-lighted work area. Don't block airfoil or baffle openings. Do test hood performance with instrumentation. Don't believe any fume hood is really explosion-proof. Do correct hood system problems immediately. Now, before we wrap up this video, let's take a closer look at a few more important details about good hood practices. That's fume hood practices. Don't ever slam down your fume hood sash. There are a system of weights, pulleys, and cables that can be damaged with abusive use. A properly operating sash is the first key to a properly operating fume hood. Your sash should open and close with ease. And the key word is slow. Always raise and lower your sash slowly to prevent spillage of fumes outside the opening. Work 6 inches behind the opening plane and keep all apparatus inside the hood opening to prevent spillage. Don't lean inside your fume hood. Keep yourself outside.
Don't store chemicals in your fume hood opening. You not only increase the likelihood of accidental spills, you restrict the flow of air and reduce hood exhaust efficiency. And don't forget the potential dangers of electricity. You should never place an electrical outlet strip or receptacle inside your fume hood work area, and closely inspect all electrical apparatus for safe operation. Beware.
No laboratory is perfect, but look to improve your situation.
Simply walking by can create unwanted air currents that can adversely affect hood performance, experimental accuracy, and overall safety. Close all doors and windows and relocate air vents that might create competing cross-air currents. Open windows and doors located too close to the hood could result in fume spillage.
Use your fume hood and know your fume hood. Know everything you can about it. It's you who are being exposed. Know its operating characteristics, the static pressure, and containment. These can be checked with a velometer, smoke tubes, or manometer. Know your exposure risks at all times. It's your responsibility. Refer to material safety data sheets and other sources to determine your level of risk. Some chemicals may require higher face velocities. Others may exhaust at lower face velocities.
Know if the storage cabinet below your fume hood is properly vented. Check your fume hood liner for any cracks and know what material it's made of. Make certain the access panels inside the hood are in place. Missing access panels can create unwanted eddies and leave your hood interior susceptible to corrosion. Know that your duct has no holes or cracks and is not leaking fumes. Know if your system has an air cleaner and know when it needs to be replaced. Know if your system has an integral blower or a remote blower. A remote blower is better. Know if the fume stack is properly located and installed. Does it have a deflection style or slanted rain cap? If it does, make sure that it is removed. Otherwise, it will obstruct efficient fume removal and disbursement.
If your maintenance people are too busy, you can call in help. Ask your fume hood manufacturer for suggestions. They know who knows about fume hood servicing. Just as you have a right to know about the kinds of materials you're handling, your company has a right to know about your operations. Report any and all accidents and any changes in hood system performance. It's part of your job to inform and be informed for your personal protection. It's not just a good idea, it's required by OSHA. Unofficial studies have shown that the cost and energy waste from inefficient fume hoods runs into the hundreds of millions of dollars each and every year in the United States alone.
So just maybe your anticipated salary increase got sucked up by your inefficient fume hood system.
The bottom line, of course, is your personal safety. It's you who are taking the risks. It's you who needs to know about your fume hood system, inside and out. Ask questions, get answers. So that's the basic story from top to bottom. I'm Vicki Verdery. Thanks for joining me today, and remember, it pays in many ways to know about your fume hood.